Hello, everyone. It is April 4th, 2023, and we are going to have a live coding session tonight. Hope you're doing well. Say hello in chat. We got code with Mujahid, Tech Wyatt. We got some tech people in the chat. How's it going? Twitch. We got Jeff. We got QueerT ____, and then a Y. I like that name. How's it going, everyone, tonight? Can you hear me okay? Is the music okay? Hope it is. So let's just go ahead and jump into this. I'm going to turn my dark mode on my browser as to not blind all of you. And I'm going to go ahead and pull this up. Now let's get it situated a little bit. We got my chat here. Got the dark reader. And this is what we're looking at right now is the Kaggle PogChamp series, which is ongoing. It's April 4th right now. The competition runs until May 1st, 2023. That means you have plenty of time to still join. You out there, you could join. You could win one of those GPUs back there. I'm not going to go and get them because it takes forever, but I have a 3080 and a 4080 GPUs thanks to NVIDIA that you could win. You just have to watch one of the sessions from GTC and join the competition. So with getting that out of the way, I'm going to put this link in the chat. Everyone here should join because your odds of getting a free GPU are just too high. We do have 115 teams joined this competition, which is, I think, the most that we've had before. I can go back to the third one. We did this one on It's Corn. We had 92 teams in that one. The second one, music classification, we did this a year ago. Was it really a year ago? It doesn't seem like it's been that long. 64 teams joined that. And then the very first one actually went down on our second one. The very first one had more teams, 88. So we've surpassed that here. Episode 4, season 1. We have 115 teams here, and you should join too. Why not? Don't you want to win a GPU? Guys, why not win a GPU? Tell me, chat. Why would you not? Geeky programmers in the chat. Tech Wyatt's saying everything looks great. Thanks. Rakesh is here. First time excited to learn. You're going to learn a lot. Buckle up. Put on your seatbelt. We got some bubbly in the house. That means I'm ready to do some real work tonight. So this is the competition. Let's look at the leaderboard. I Know When You Sleep is winning by a lot on the public leaderboard. Keep in mind that this isn't what actually you get scored on for winning the GPU. That'll be the private leaderboard, which we won't find out until May 1st. But we have some others. GB4. I win in the number of attempts. This is Sebastian. He does have 45 attempts. He's barely beating Team Paris, who has 42 attempts. So he technically is winning in that category. So a lot of people, 150 people here too, and you could join. Oh, I never put this in the chat. No, I did put this in the chat. Great channel, great material. Wish I had more time to commit. You don't even have to commit any time other than clicking that link and then clicking join and submitting a baseline submission. So let's look here. If we go to the code tab and we go to buy, just be as lazy as you want. You just you sort by best score. By the way, upvote these. You can't tell because of my dark theme, but I think I've upvoted most of these. From ZZZs to XGBoost, you would just take this notebook, click copy and edit, run it all the way through it, then take the, or I think you could just take this output. Let's look at the output. Come on, load. Don't fail me now. Don't fail me now. There is no output. How is there no output? There has to be an output. Maybe it's this version doesn't have an output. So let's go to a version that does have an output. Version 21. Output. Here is sample submission, maybe? Yeah, this looks like it's the person's submission. So if we looked at this code, we read it, we understood it, we maybe modify it a little bit, and then we take it when he writes his sample submission output, and we take that output and you submit it to the leaderboard by just doing this, clicking on it. Where's the submit button? I guess you might have to download it. It might be like 3 steps. Download it, go to the competition, click on submit. Oh wait, don't look at that. Oh, I guess that's not that big of a deal. And click submit predictions, and then you'll upload the CSV file here. Then you're on the leaderboard. That's all you have to do. Okay, so we've talked about that, right? Now let's talk about a different competition that I've been kind of getting into. So we all took a look at this competition. It's being put on by Google/PopSign. I guess PopSign is like a game for learning American Sign Language, but we started looking at this on the stream because we took a poll and everyone wanted to look at this one. And then I got pretty into it. And I've been thinking about it a lot, and I've been creating some models. And now, what do you know? Like on the public leaderboard, I'm 10th place out of 843 teams right now, which is like, okay, it's still pretty early in the competition. A lot of people haven't really joined yet, but I'm doing okay. Now, the thing is, to get better, to make my model even better, I want to better understand how this data was created. So in tonight's stream, we are going to be trying to recreate this model essentially, or this data set. So we're just going to go ahead. I'm not going to reveal any of the specifics of what I've been working on in this competition, but we're going to actually take one of these models. Someone actually, this guy's been making some great notebooks and just uploaded one today. That's a pretty good leaderboard score. I think it's that would get you into like the, top percent. Well, not now because everyone else has probably submitted the same thing. But the cool thing and kind of frustrating thing about this competition is you're required to submit your model as a TensorFlow Lite model, a TF Lite. And that means that it can run on edge devices like a cell phone, which you could imagine would be pretty important if you're trying to predict something like someone's webcam and when they do a sign for sign language. So we are going to actually use this person's top model and try to create the data ourselves to predict on it. That sound cool? And we're going to do that using what they've created, what they've used to create the training data set. And if we go to this data tab, we'll learn a little bit more about that. I guess they don't say it there. They say it here. So the goal of this competition is to classify American Sign Language. You will create a TensorFlow Lite model trained on labeled landmark data extracted from using the MediaPipe holistic solution. I've made some, I don't know if I've made a video about MediaPipe. I think I have. Yeah. But, you could check that out on YouTube if you're not on YouTube. ! YouTube. Please speak more calmly. I can't. I'm too excited. I'm sorry. And you saying that just makes me want to be less calm. All right, so we're going to look at MediaPipe Holistic, and we are going to try to run it on myself and I. So, yeah, let's go ahead and do that. I have here my handy dandy terminal. Can you guys see this? This is my webcam / Canon camera that's running, my wife's Canon camera. And then I'm going to open up my repository where I have this repo specific for this competition. Now I do have this folder that I created right before I started the stream called Holistic. So you can see in this Holistic folder, I have a file called holisticcam.py. This is a Python script. And if you look at it closely, you will notice it closely resembles the code that you see here in the Holistic documentation. That's because I almost word for word, or like, I can't speak. Okay, so not word for word, item by item, line by line, copied this code into this script. And we're going to try to understand what the script does again a little bit. So the main thing is we're importing something called CV2, which is OpenCV. It's like the backbone of what a lot of computer vision models and computer vision stuff uses. Then we're going to also import MediaPipe. MediaPipe is the package created by Google for doing pose and face detection and hand detection. Now, what are we going to use CV2 for? We're going to actually create a camera that's here. We create this webcam. We're going to try to do this a few different ways. Okay, so this is for static images. So I actually want to just take all this. I guess I could just delete it. I just deleted it. You guys probably don't see that because I just hit D and it all deleted. But we're just doing it for webcam input. So let's do it with our capture device 5. So that is one of my other cameras. I forget which one camera exactly. But we're going to open up this holistic object. And then it's going to take this camera and pull in whatever frame or image is in that camera at the given time. It's gonna, I don't know what frame rate it is, either 30 frames per second or 60 frames per second. It's gonna start, we're gonna start looping over that with a while loop. So this is just gonna keep on going forever until there is no more camera available. The camera either goes offline or I kill the script. It's gonna then read this. So whenever you have a CV2 object for video capture, either a file or a camera, you call this read method on that capture object, and it will provide you two things. It will say success, and this will be a true or false, a Boolean value. Hopefully it's always true if this is running. And then it'll give you the image for that frame. Because video isn't really video. It's just a bunch of images back and forth, right? Or on top of each other. You're looking at them in succession. So this breaks out if this is not successful. Otherwise, it's going to take this image, convert the color, then it's going to process it using this holistic model. That's going to give us our results. I'm not sure exactly how these results are formatted, but I know how they're formatted for the Kaggle competition. So we're going to try to pull out this eventually. And then, so this is like the main chunk of what I'm trying to do here is just run this on a video file or on my webcam. This part is to give us a pretty output. So this part just gives us the pretty output where it's going to draw some landmarks. So it's going to draw my face contours, draw my pose connections, and then it's going to show it. So let's go ahead and try to run this. Should we try and run this, people? What do you think? It's Lord of the Rings dialogue. What are you talking? Hello, greetings from Bogota, Colombia. Welcome from Colombia. How's it going? I wish I can join once the computer. I wish I can join you once on computer vision topics. I've been teaching computer vision for a while on YouTube. Oh, you have Tech? Wyatt? What? Tech what? That's pretty cool. Okay, let's see what I do. So let's go into this and run holistic camera. Okay, no module named MediaPipe. That's because I have to activate my MediaPipe Conda environment. And if I do a Conda list in here, it's going to show me everything I've installed in this Conda environment. Conda environments are a way for me to separate out my Python projects into different like bins or different environments, right? So now I'm in the MediaPipe environment, which I just named MediaPipe, but I've also installed MediaPipe on there. I think it's an older version of MediaPipe. We're going to have to figure out exactly which version of MediaPipe they used for this competition data, but that's another thing. Okay, so now it should actually work. If I see this holistic cam, Python, holistic cam, let's get holistic with it. All right, it doesn't work. So video device 5 is not a device. So, always forget this command. Do you guys also have Stack Overflow pages that you search for on Google and then it's like purple because you know you've clicked on it like a million times? Because I definitely have that. Okay, so this is a command I can run to see all my web cameras. So I think I could use this Brio one. What does this mean? Is it on video 1? All right, so let's go in here. Let's edit this holistic camera. Right now I have it going to the capture device 5, which I guess doesn't work, doesn't exist. I'm gonna change that for 1. Let's actually just edit this up here and then down below it. This is where we will run holistic cam. Come on, don't fail on me now. Okay, video 1 does not work. Hold on a second. Wait, hold up. Hold up here. I listed my devices. Hold up. Look, this video 5 should be my... All right, let's try video 0. Not that. I'm going to save that. Oh my goodness. It worked. What camera is this? Is it this one? I always have to... Wait, how is it this? It's using the same one I'm using to stream with. That's weird. I didn't know it could do that. Okay. So this is working. Look, it has... It's only drawing certain points. I don't think it's actually detecting my hands. But it's actually detecting like 500 points on my face, but we're only displaying some of them. So I want to... Now, that's pretty cool, right? You guys understand what's going on? So I'm going to kill that session and actually... Hello? Okay, yeah. So now my camera is broken. Now my camera is broken. Look what you did. Look what you did, Rob. Look what you did. Maybe I could just stream the whole time through the other way. Okay, so now I'm back. I had to reset it in OBS, but now I'm back. All right, let's not do that again. Let's not do that in the sense of running from that camera. Let's try to run from video 5. This is why I don't understand. Why isn't it not working for 5? It was working for 5 before. That's my other webcam. Can't open camera by index. But why not? Maybe it's 6? I don't know why this UVC camera has multiple video. We're going to get it, guys. We are going to get it. How about 4? Oh, is it because... Oh. Shoot. Is it because my OBS is using it? Oh, okay. So you're saying instead of this, I could do dev video 5. I think I know what's the problem, though. Thank you, Sudar, for this help. But I think the problem is that it actually is being used by my OBS right now. Like one of these. Yeah, like this is a different camera, right? I have too many cameras here. This is this one, the one that I'm trying to use. I need a leading slash and dev. I still don't think it's going to work. See? So what I need to do is... How do I reset? I think I can... I think using this, I can reset device. This is why you test things first. Video for Linux control panel. Yeah, if I go to like, how come it let me do the other stuff though? Here's what I'll do. I'm going to unplug this other camera. Then I'm going to plug it back in. Or I could have done that to this one. Yeah. When all else fails, this is computer vision, people. It's unplugging and plugging in. Ugh. Oh, I'm going to break it. No, I'm not. Hopefully not. And now I need to really make sure I get this running. Created TensorFlow Lite. Oh, wait. So this uses TensorFlow Lite. I guess that makes sense. Let's try to replace this with 5. See when that camera's rebooting. And do list devices. So this is here as video 8 now. Let's try it on 8. We're gonna get it, folks. Stick with me there. Stick with me here. Can't open it? What is going on? Let's try 6. Yes! Finally! You guys had faith. LOL? What's up, Colin? Okay, now I have this other camera. Which one are we using now? Computer shaking your head. Now we have this camera, which is, I think this one, yes. And it's doing a pose detection and hand detection, but this is just the main hands for pose. So what I'm going to do here is I'm going to stop this again. Now that my main video works, and I know that I can run it on this one, 6. And I want to actually print the results. That might be kind of crazy. That's probably too crazy. I'm going to have to just run this for like 2 seconds and then stop. Let's see what the actual raw results look like. Okay, so the raw results are these MediaPipe solution. It's this MediaPipe based solution. So now's the time where we hop into, we get nice and cozy, and we hop into a Jupyter session. Let's open up Jupyter Lab. Let's do it, folks. Guys and gals, I understand nothing but enjoy being around. That's like the story of my life. And then you slowly start understanding things. So I actually started this with the wrong con environment. We're going to switch here to MediaPipe. All right. So we don't really need to run this. The thing is, we don't need to run this on a webcam. But let's just go ahead and do it since we have this code to do it. So we're going to run this on a webcam. Can you all see this okay? I'm running this in this Jupyter environment because what I want to do here is actually break after running this once. So it's going to take a single picture and then we're going to create. Oh, I did it too early. We want to do it here when we print the results. We'll break here. So now we'll run this one cell in this Jupyter environment. You guys following me? Can you do forecasting to supply demand for a small size company? No, I can't. Good old Jupyter. Vim gives me a headache. I love Vim. You better not talk bad about Vim. All right, so now if we look at this output, it is a MediaPipe solutions output. If we just like Google this, we probably get to the GitHub repo for it. And I don't really know anything about solution outputs. Process a set of RGB image data and output solution outputs. But what are solution outputs? It looks like it's just a named tuple or tuple, depending on who you ask. So let's go. If that's the case, then this should have some keys to it. But it has no attribute keys. It has, okay, so what it has is count, a count method. This is a nice thing about, it has these face landmarks. See this? It has left hand landmarks, which were none. All right, so let's run this. Let's also import matplotlib pyplot as plt, and we'll show this image. Yeah, so that's the image. There was no left hand, so that's why, that would explain why there are no left hand landmarks. But let's try to run this again with my hand up. All right, now let's look at this image. And it was taken from when I was like closing my eyes. So we're gonna run it again and hold my hand up for a long time. All right, I saw the light flash, so I'm pretty sure. Okay, it's got some of my hands. And sure enough, there are left hand landmarks. How does it have so many landmarks? I barely am showing my left hand. And then right hand landmarks, there are none. What's the segmentation mask? Well, there is none. Pose world landmarks. And what else do we have? Now it doesn't want to show me anything. So let's just be silly here. And import pandas as PD. Do I really not have pandas in this Conda environment? Oh, wait! Oh, wait! This Conda environment doesn't have pandas. And I'm about to install pandas into it. And guess what? As of today, if I go and pip install pandas, it's going to install pandas 2.0. It just was released. I think today, maybe yesterday. Maybe yesterday. So let's activate MediaPipe. And let's pip install pandas. Let's see what version it installs from the intranet. That's right, 2.0, baby. The legit 2.0 version. And now we go in here and we print our pandas version. And it is 2.0. History in the making right here. Waddle Waddle knows what's up. I think it's clear if you look at the MediaPipe homepage. So I do have, what's clear? I think I kind of understand what's going on. Trust me, because of this competition, I have been looking at MediaPipe landmarks a lot. A lot! But yeah, we can look at their homepage. Send me the link that you're talking about. I'm watching the stream on YouTube, but I come here to support on Twitch. You need to go on both. Yeah, but Twitch is much cooler. Twitch is a lot cooler. All right, so if we take this results and we take the face landmarks and I do PD data frame on this, it's not going to work. It's just not going to work. Because this is, the type of this is a name normalized landmark list. So basically what we want to do now is iterate over this. I don't know if this is the best way to do it, but we're going to iterate over this by enumeration, and let's see if this works. Oh, we need to say in. What? Wait, what? It's not iterable? We can't iterate over the face landmarks? Why does MediaPipe have to be like this? I'm sure it's some sort of efficient way of doing it. So I have these values. I can't iterate over this, and I can't access them subscriptable. So how do I access these? I can do landmark. Oh wait, dot landmark is a list. What's this? Why does MediaPipe have to be so hard? This is a repeated composite container. Google just doesn't want to use base Python stuff. So I bet this is not iterable. Oh wait, it is. All right, so in each land, can I iterate over these landmarks? Now we have a point. This is just the string representation of it, but I bet it has like, yeah, as a dot X, dot Y, and it's going to have a dot Z. Sounds like it'd be a cool like stage name for me. Dot Z. Yo, what's up? I'm Dot Z. All right, so we're going to make a blank data frame that's going to store these landmarks. Then we are going to locate at the point number. And we're going to put the X value is this. Watch out, guys. Point Z is coming to your neighborhood. X, Y, Z. If I knew how to do ordering of letters, that would be helpful. All right, so now we have a landmark data frame. Let's go ahead and plot X is X and Y is Y as a style scatter. Let's see if this works. Probably not a correct D type. Yeah, so they're not as integers. So let's go to landmarks. Wait, that should work then. If landmarks X is a float. Yeah, so I can plot this. Oh wait, kind equals scatter. There we go. There's my face. There's my face. Now, Y, in order to plot this, Y is kind of needs to be upside down. So let's do this. Let's just replace it with the negative version. All right, but that's my face, right? Do you ever use ChatGPT as a tool while you code? Some, but I've been using, when I use VS Code, I use, I have Copilot on, which can help sometimes, but sometimes it's just bugging me out. That looks like your face when you are on acid. Okay, Mateo. Mateo knows what's up. You can write landmarks like this. Oh, that's a good point. That's a good point. So what who said this? Doji said is I could just write it like this. Yeah, so that will give me the same thing. Which is cleaner? Which is cleaner? Probably this is faster. But this, yeah. Repeating writing landmarks.loc so many times is not nicer. So let's delete this. Good suggestion. Every time I do this, it should flip, right? Because I accidentally put that there. But now we got the face landmarks, right? Let's just call this face. All right, so now we have face. Now let's do the same thing for our other landmarks. I probably should. So we're going to do pose. Probably shouldn't repeat code here like I am, but I'm going to because I'm lazy. Face, pose, left hand, and right hand. I think, what's it called? Left hand. Yep. And right hand. This is where I miss using Vim because I can do things a lot faster. Yeah, because speed is totally my problem right now. I'm joking. I'm joking. Okay, so what's the problem? What's the problem here? Attribute error pose. Oh, so this is called like pose landmark? What's it called? Results? Oh, what am I doing here? Pose.landmark. And then left hand.landmark. I'm sure I'm going to check chat and someone's already mentioned this. But yeah, I'm stupid. What did I do wrong? Solution output has no attribute pose. Okay, results dot pose landmarks dot landmarks. And then this is probably left hand landmarks and right hand landmarks. None type has no attribute landmark. Okay, but that's because one of these hands, the right hand, it probably broke here on the right hand. Yeah. So we should do. Man, this is kind of annoying. Is this annoying to do it this way? So let's put all the data frames here up at the top. I probably could just do like a NumPy arrays, but data frames make it a little bit easier right now. And then I'm going to bump all these over. Let's also put this all in one line to make it nice and pretty. There are no mistakes. There's just happy little mistakes. What is that quote? So now we want this to be here, here, and here. Let's see what's going on with the chattertude. There are no accidents. There are just happy little what? Hey, why don't you use Jupyter but the browser instead? I am in the browser. What are you talking about? I'm in a browser right here. Wait, that's the quote? Happy little accidents? Oh yeah, there are no mistakes. They're just happy little accidents. But accident, just isn't the word accident mean it's a mistake? Come on, Bob Ross, step up your game. Bob. Why is this complaining? Oh, it's because I haven't indented this. I was getting really mad there when it was my fault. Wait, that's always the case with code. It's always the case. All right, so we're going to plot our image. Then we're going to show our landmarks, right? So we have face. And then we should assign. All right, so now what I want to do, folks, R.I.P. Bob. Yeah, I know. I'm telling him to step up his game, and he's been gone for a while. Bob Ross is like pretty cool though. You mean Jupyter Notebook? Oh, well, because Jupyter Lab's better. That's why I'm using it. How dare you come here and tell me what to use? How dare you? All right, let's better understand this Kaggle competition data. So I'm going to send you guys. Do you need the is not none? Doesn't just work if X. True. Very true. Very true. Will this work? I don't know. I just have always made it explicitly not none. Is that not cool of me to have done it that way? What's the difference between Jupyter Lab and Notebook? Hey, great question. Go to YouTube. I'm not being patronizing, by the way, here. I'm just trying to actually promote myself. But if you go to youtube.com/RobMulla, and I'm going to put this in the chat. If you go here to my page, you subscribe, make sure you subscribe. You go to videos and you look at this video. One of the first ones I made. I talk all about Jupyter Notebooks, Jupyter Lab. I explain the difference between them, and you should check that out if you haven't already. All right, so Kaggle competition data. So let's do PD read Parquet, and I'm going to read in this input ASL signs data. And we're going to pull in an example one. Actually, let's pull in the train CSV first. PD read CSV. ASL signs train. There. And then we will pull in one of these random Parquet files. And we'll call this XYZ. Examine your Z. I don't have PyArrow or Fast Parquet installed. Ooh, pip install PyArrow. Installing packages. I have a problem with Kaggle competitions ... ML Boost, do not bring that crap here. I don't want to hear your problems. I got 99 and you not liking Kaggle competitions is not one of them. I'm just kidding. Okay, tell me it. Tell me it. What is it? The other way to do is put things try except blocks. Yeah, I do not want to do try except blocks for this. I don't even want to do this. I don't want to do anything. All right, so if we look at XYZ, we can see that what they have here is for each frame. So let's look at frame 83. This is in the Kaggle training data. Let's actually also look in this train query sequence ID equals, it's going to equal this one, this sequence. So this sign is green, the one that I pulled up. It's frame 83. So here. So if I look at the XYZ data, it's 57 rows, 57,000 rows. But what does that consist of? A bunch of different frames. And for each frame, we have 543 features. Now, if we go back to the Kaggle competition and we go into here, we could see how they expect the data to be read in. So when you load in the values for, it'll just take in all 543 and it's gonna pivot this basically so the data is in a different shape where it's frame by point by XYZ. So we're gonna see this. We're gonna run this function. Load relevant data, and we're gonna call this our parquet file. So instead of just using read parquet, we're going to feed this in our parquet file. And it's going to fail because I don't have NumPy imported. Let's go ahead and import NumPy. Now what do we have? Now we have our XYZ in NumPy format. This is in the format 105 by 543. Recognize 543? That's the number of landmarks. By 3, which is XYZ. That's the shape of this. Now, pandas you can't have. I guess you could have a multi-index, but this is the better way to do it. So if I do here, index 0, this is XYZ points for 543 points. Yeah. And let's go ahead and test this prediction on the public person's notebook code. Using their TensorFlow Lite output. This is their model. And we are going to go ahead and download this bad boy. And we are going to move this from our downloads folder into this folder. Then I'm going to create a new Jupyter kernel in my other environment that has all the right installs. And we're going to say inference, TF Lite inference. Run TF Lite inference on an example data set. All right, so now in order to do this, we need pandas, we need NumPy, and then we need to load the relevant data. And then I need to remember how to do the inference. I can just copy this code. Yeah, so we have to run this, open up this TF Lite interpreter. Let's go ahead and do it this way. Our TF Lite file is just in this directory, so we can just do .tf Lite file because I moved it in here. Yeah, so this should at least load in our TF Lite model. And now we have a prediction function that takes in a file or takes in data in this format. So now let's go back here. Let's copy this. Let's get our XYZ and NumPy like this and feed this bad boy into this parquet file. Oh, sorry, this XYZ NumPy output into the prediction function. Let me remember, because I think it has to be a dictionary, maybe. Why isn't this working? Why? Why, oh, why, oh, why, oh, why, oh, why? Why is my life so hard? It isn't that hard. All right, this prediction function takes 2 arguments. No, it doesn't. Maybe I need to call it with specifically calling inputs equals this. There we go. There we go. Now we have our prediction. This is a dictionary with outputs key. And in that output key, we have a NumPy array of shape 250. 250 is the number of signs that we're trying to predict. And if we do something like make this a panda series and then plot it, we can actually see the prediction for, let's make this, it's going to look gross, but let's make this a bar. You can see there's a prediction for each of the different signs out of the 250 potential signs. And there's one that's spiking up. So the way we identify this is doing arg max, which will give us the location of the one that is spiked. And this is our sign that we have predicted using this model file. But now we need also to load in the training data so we can actually see what that sign should be and is. We need this ORD to sign. We basically need these mapping functions. Sign ORD does not exist. Okay. We almost got it. This allows us, these dictionaries allow us to translate between the values between 1 and 250, or 0 and 250. Or I guess it's 0 and 249. And the actual sign name. Let's make sure. Yeah, 249 is the max. So we take this sign. We map it back. And it predicts green. Was green the actual value of this? No, I think it's wrong. I think it's wrong. I'm so sorry, model. You did wrong. Oh, wait, it is green. It is green. Yay. I went from really sad to happy there. You guys follow me? Just came in. What ML model do you use for prediction? So I've been training my own for this competition on Kaggle. Which, not this one. That one's a cool one, but not that one. I've been training my own to get here, but I'm not using that one. I'm just using one publicly available here on Kaggle, which someone has created training on this training data. So it's just available here. But we're also using MediaPipe to create raw data that looks like this. Yeah, this is a type of EDA. Will there always be a spike? You'll see. We can look at some of these, but you'll see some of them. There are 2 spikes or 3 because the model is confused. Just like me most of the time, this model can also get confused. Is this sign language competition from earlier? Yes, it is, Justin. I hope in 20 years sign language will not be needed. I don't know. Some people like it. I think if you like it. Also, it's good to teach your kids, right? When they can't speak. Do you agree with the statement? Okay, this is ML Boost's problem with Kaggle. I certainly acknowledge your Kaggle accomplishments. Okay, as long as we start on the same page. My problem is perhaps a little theoretical, and by no means disrespect. A lot of prepping me for you to say something bad. Do you agree with the statement? It seems like you're boxing me into some sort of yes or no. That's probably both going to be wrong. One may badly lose a Kaggle competition even when he/she has built the best possible model. No, I disagree with that statement. If that's possible, then the onus is on the person who created the competition. It's not on the people who are solving it. Are you in spring with these freaking summer files? Be hitting myself monitor stream 24/7? What are you talking about, Startup Me? That makes whatever you just said makes no sense to me, but probably because I don't have the context. No, sir, just to understand things. Yeah, I know, ML Boost, I'm just kind of joking around here, but yeah, there are some poorly designed Kaggle competitions where not the best solution wins. But working in big companies, this is the problem with people who want to apply machine learning in an organization or just in general, but they can't clearly define what the objective is. They just want a good model. See, what frustrates me about what you said is one may badly lose a Kaggle competition even when he/she has built the best possible model. By what definition? So we all have in our head what we think is the perfect model for some problem, but that's not how it works in machine learning. How it works is you define the metric. You define some way of saying this model is good or bad. Even with ChatGPT, human labelers went in and they told the model, you're right or you're wrong on these specific instances. So there is a ground truth, right? Summer/spring. In Atlanta, they make me crazy here in the seasons. Oh, I like these. There's nothing that frustrates me more is when someone says, and this isn't what you said, ML Boost. Best possible model equals model that is exactly the same of true underlying model. What's the true underlying model? What were we talking in circles here? But there's nothing that frustrates me more than when someone says, let's just test out and see if the model's good enough. Good enough for what? How good does it have to be? We define what's good enough. All right, I got all heated up there for no reason. I'm sorry, everyone. I'm sorry. All right, so these are the predictions for this output. This is for green, the word green. Now let's find one of the words. Show an example. Okay, so here's the problem too. This model has been trained on all the training data, I'm realizing, because this person actually trained on all the training data. There's no folds. So we're not really looking at a true out of sample prediction. So yeah, we might see full spikes like this for almost everything. Actually, I think we will. But let's try to create our own data set. Let's go back to this other tab and try to create it. Best model equals found global minima, maybe? But you never know what the global minima is for the problem. Like if you were to ask me 2 years ago what the best language model could be, I would not say ChatGPT, but now I know it's there. So that's constantly what we're trying to do in data science, or at least model building, is try to figure out what the best model is. Like, can you perfectly predict the weather tomorrow? Is that the most important thing? Is the most important thing that you predict it perfectly every minute? Is the most important thing that just on average per hour that you have it right? Or is the most important thing that you just for the day can predict one of the hours exactly correctly? I don't know. There are a million different ways we could define what the best model is to predict tomorrow's weather, but it's up to us and up to the business people to figure out what that means. And it involves a lot of thinking. It involves a lot of like really understanding the problem. So we're back here. So we have this XYZ. Now, the way they've done it here is they've given, if we look at face, let's just do type. If we do this, we can see that we have 468 face landmarks, 33 pose, 21 left hand, and 21 right hand. That's the maximum amount of points that we could predict for each frame. But we'll notice here that there's a lot of missing values. That's because just like my right hand wasn't up when I was filming that earlier part, there will be no values. There will be no predicted landmarks for my right hand in those frames. So let's try to get the data into this format. Let's try to get our data into this format. So what we will do here is we're gonna all right, and let's again, just for people who are just joining us, what we're trying to do if ML model can be generated exactly that data, then it would be called an ML model, the best ML model. But most of the time, you're trying to train an ML model on data to predict future or unseen data. Otherwise, you know what that machine learning model is called? It's just a SQL query. It's a lookup in a table. Have you ever seen Nano GPT code in video? No, I haven't. Oh, wait, you're asking someone else. Real talk. You'll never know the global minima with that attitude. I like it. So you don't do typical data science pros, train, stress, split, train. I don't understand what ML model is exactly. No, that's right. So we're just trying to, we're not actually training and evaluating our model right now. We're just trying to do some data munging to create data in the format that this model can predict. That makes sense? Are the nans dropped or zero? So that's dependent on the model, but the model needs to take in nan values for those. So what we are going to do now, what we're going to do first is I'm going to show you all that we are running this holistic cam. Please work. Please don't break. So this is running. If I just run this, right? So it can detect things. And it's not actually showing all the points that it's detected. That's just showing a subset of the points. So I plotted here. Yeah, so we did it earlier, but we plot x equals x, y equals y, kind, scatter. We could see from this image up here, we pulled in my face, which looks like this. It's upside down because the Y is inverted. But we want to format this in the same way. So we're going to make another blank pandas data frame. Actually, let's just look at XYZ. Yeah, let's take a blank data frame. And we're going to call this one landmarks for real this time. And in XYZ, first is the face landmark. So I'm just going to assume that the landmarks are in the same order. So we already saved off those. And this should be of shape 468. 468. Perfect. So let's assign. No, let's reset index. Let's rename index to be, what do they call it here? Landmark index. It's probably exactly the code they wrote. Probably what I'm writing is better than what they wrote. I'm just kidding. This needs to be columns. Now we have landmark index, and then we're also going to assign the type equals face. Don't like using type as a column name just because type is a default Python thing, right? That's a default function. Try to avoid those. Like don't name a function print. Don't name a function eval. So now we have this face. And we're going to concatenate a bunch. So we're going to concatenate first face. Okay, so there's something we have to do is there's something we have to do here in between. So I can't just concatenate them yet. Will it always be 468? Are any of these null? All right, so let's do this actually to all three of these, but it's not going to work for right hand. But let's try it for pose. Left hand. And then what we need to do is like merge it on a blank data frame. Wait, but right hand? Yeah, oh, okay, so it's just gonna be empty. All right, so what's the shape of left hand? 21, perfect. Pose, 33. That's right. Okay, so what we are going to do is this thing I hate about pandas concatenate is you can't just concatenate all these together like you could. Oh, wait, you can. I'm an idiot. Look at me. Reset index, and we're going to drop that. Look at us. We didn't even need to make a data frame that we would put this all in. We don't even need to do this. We got it here. Reset index only. What in the world? Reindexing only valid. What? It didn't do this before. Oh, I keep on running this cell over and over again when I actually have to do all this together. Right? This actually needs to come after this. All right, now we have our landmarks. Drop this. We're going to do it, folks. We're going to actually do a prediction. The payoff is going to be at the end of this when we actually predict hand motion. I missed out pretty much on the first hour of the stream. The topic looks super interesting. Will you be reposting the stream? Yeah, as soon as I'm done, it's on my YouTube channel. So go check it out at youtube.com/Rob Mulla. Would you please make a video about making API and web apps in Python? I could, but I'm probably not the best person to make that because I don't really do that. I could, though. Let's make this a function. Create frame landmark df. And we're going to take the results. And we're going to create a landmark data frame. Now, there's still one thing I have to do to fix this. The one thing we have to do is we have to take this train file. Oh no, we need to take our XYZ file, query where frame equals 83, and then we need to do a type landmark index. And we're going to copy this, and we're going to call this our XYZ skeleton. Why are you doing this, Rob? Why are you so weird? Why are you making a skeleton? The reason why is because we want to have values or rows for every type and landmark index. Yeah, so I think we could do it. We could actually do it this way because this won't be dependent on the frame. And this is kind of a lazy way of me doing it, but it's going to work. And then we're going to merge this on our landmarks on our type and landmark index. How, you ask? Left. That means that our skeleton will always have those landmarks even if they don't exist in our results. So let's go ahead and call this. Let's go ahead and call this and get our landmarks. And look at this. Our right hand has null values because we didn't actually do anything with that. So that's cool, right? You guys following? What ML do you think we'll use for prediction? So we're using a TensorFlow Lite model. This is a transformer-based model that was posted on, because I don't want to talk about my model. This is a really good one out there. It's a transformer-based model that was trained using TensorFlow. You can see the whole architecture here. They have embeddings for the hands, for the lips, for the pose, and it takes it all in and it does its prediction, and it has about a 0.71 accuracy in terms of predicting the correct sign using American Sign Language. So what else should we do here? Oh, we also need to add in a frame number, and then we're going to take this landmarks and we're going to assign frame equals frame. And now we need to give it a frame, which would be like 0 here. And now we have an actual frame. So now we can make each of these unique. Cool, 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 cool. Okay, so now we have these results. Now what we got to do is film ourselves doing some sign language. What do you think, guys? Should we look up some signs? I didn't know Python was intricate until I started learning it. Everything's intricate. Are there many multi-person examples in the data set? No, they're all a single person, single hand actually, because they're using their phone to record themselves do the sign. So what's a good sign that we could do? If we take train and we take sign and do value counts, let's do sh. Let's look up how to do sh in ASL, American Sign Language. It looks like this. Shh. Just like all you in chat should do right now. No, just kidding. Shh. Just like I should do right now. Shh. Also see quiet. Okay, so that's how we do it. Is there also a video? I think that most of these have, if you go on YouTube, how to say quiet in sign language. I guess it's the same thing. Okay, so that's different. That is quiet. We want to know shh, shh is like this. Shh. All right, so I'm going to go ahead. What I'm going to do, let's put it all together. Let's put it all together in a script. Let's get away from these notebooks. And let's actually create a Python script. Capture sign.py. All right. What our capture sign is going to do, it's going to have this same import, but we're not going to do this with the results. We're not actually going to output the results, or should we? Let's go ahead and output the results. Let's make this a function. We're going to call this do capture loop. And then we're going to put this in a try. We're going to put this in a try and accept. And we're going to return landmarks when this breaks. How are we going to get landmarks, you may be asking? Well, just quiet down there. I'm about to show you. We're going to do this. We're going to pull this function in that we wrote called create frame landmark data frame. What we're going to do here too, as we we loop through the capture, is we're going to take frame, we're going to increment it, and we're going to say, oh, this is the dreaded 2 spaces indentation from Google. Thanks, Google. No, I'm not hating on Google. I just need to switch this around to make indentation consistent. It's gonna be annoying. So there's not that many indentations, right? We can get through this. If wait key, oh, what's that wait key? And then return landmarks here. I think this should work. And we're actually going to do the drawing. And then we also need to do here. And then we're going to get our landmarks data frame. When does it get the results? It gets here. So here we're going to create land. I hope you guys can see this. Create landmark data frame. Landmarks all append. And then we'll append these landmarks. And I called it all landmarks here. We're going to return this if name equals main. So if we call this script, we're going to do the capture loop. And then we're going to take that, all landmarks. What are we going to do with it? We're going to concat these landmarks, reset index, and then we're going to parquet it, output.parquet. Let's see if this works. It's probably not going to work. What are the odds this works? Raw landmarks. Does hand matter? Is your camera flipped horizontally? It shouldn't matter. Most of the people in the data set, I'll say this, are one-handed. They prefer one hand, but it shouldn't matter. What are the odds out of 100? Never understood the point of name equals main. It's very simple. It's very simple. If I was just to say, screw this if name equals main, if I was to say that, and I just took this out, right? And now I run my script and la-ti-da, it works. It works great. But if I ever wanted to import do capture loop from this script into another script, I can't import it without also running this, which I may not want to do. So by putting this in a if name equals main, it allows myself to import from this file without having to run this stuff. Hey, to parquet. Good catch. Thank you, Varun. Let's see. Okay, so it's already not working because of this stupid indentation. I didn't want to do this. Close your eyes, everyone. Don't look at my solutions. But what I'm going to do here is close these down, and we're going to actually do this in VS Code. I've been trying to avoid this so I didn't accidentally show anything, but I think we're good. I think we're okay here. Okay, so now if I save here, oh, I see what the problem is. This all needs to be indented. Right? Now I save this, it's going to apply black formatting on it. And now let's try to run it. Let's go. Create a TensorFlow Lite. Oh, no objects to concatenate. All right, so this is why you don't have global try except statements. Because now I don't know what the issue was. Why am I in here? I should discard these changes and go over to VS Code where we are now editing now. I'm going to comment this out. See, I wanted it to be able to work even when I hit Control C to end this script. Let's go. XYZ is not defined. That's better. XYZ. That's right. We never defined XYZ. We need to make that an input to this function. This takes the results from MediaPipe. This is how you guys can see the autocomplete is Copilot trying to help me out. Results of MediaPipe and creates a data frame of landmarks. I guess that's true. Inputs. Let's see if it can try to autocomplete it. Results. Frame number. This is close. Data find XYZ coordinate. I don't know. XYZ example data. And then we are going to oh yeah, then we still need to put this XYZ skeleton in here. And we need to pass this through. Create frame landmarks. Did I mess up this order? Results frame XYZ. Okay. XYZ. We're going to examine our zippers here. We're examining. We're just going to make this. We're being lazy here. We're being lazy here. And I just want something to work. Just make it work. Make it work, Rob. Make it work. Hey. Hi. Oh, wait. We were supposed to do this. Shh. All right. That's what I did. Now, if I Control C, now that's the keyboard interrupt. I think the way this code is written is all right. I hit escape that time. Was that the correct? Yes. So hitting escape actually, what that does is escape is this wait key. And then that calls the break. So now this is pretty cool. Now if I go to my TF Lite inference, on my data. So now we're going to run that same TF Lite inference to try to predict what sign I just did, but using the TF Lite model that we took earlier. So now I am not going to read this. I'm going to read my output parquet. What's the sign it predicted? 194. Or to sign. Let's predict it. It predicted. It worked. It worked. It predicted that I was saying shh. It took in this data. All right, so let's XYZ. Let's make this into a data frame. Oh wait, it can't. Let's look at the length of this. 17 frames. So let's look at frame 10 and let's plot X equals 0 and Y equals 1. All right, so it's kind of hard to tell here. We're going to flip the Y axis. We're going to make this Why are you breaking now? Oh, wait, there's no why. Okay, so we need to do this. Columns. Let's give it a column X, Y, and Z. I hate that this stuff's in the way. Now this X is going to be X. Y is going to be Y. That's me. That's me. And this is every frame. So for frame data in enumerate XYZ NumPy, we are going to create a new plot, and we're going to title it frame number is no shape of past values is 3, 1. What? Wait, what? Oh, that's because this should be data. That's frame 0, 1, 2, 3. Is my hand eventually get there? There my hand is, but you can't see the lines connecting them, so it's kind of hard to tell. So there are actually people on Kaggle who made it. Oh, shoot. Where am I? Rob, would you mind doing some video sometime soon about the best practices when it comes to handling really large data sets? I could try. We did it, guys. We did it, though. We ran this model on that, and it predicted it correctly. There are some people who made notebooks that animate this. Animated data visualization. So maybe so it makes a video like this out of the data. Let's try to do that. Let's just copy this. Download. What's it called? Animated visualization. And I'm going to run this. Thank you. Credits to this person who made this notebook. I'm going to put this in the chat. Credit to them. Ah, why is it asking me to log in? What the what? What the? Restream.io, what are you doing right now? Where's my chat here? No! I hate you. But I love you also for giving me free restreaming. All right, I guess I'm not going to put it in chat, but just believe me. We're going to change this input directory. And then we're also going to change this file. So let's rename this file. Let's move this output file and call it sh0.parquet. Now we have the sh0 parquet, so I won't accidentally overwrite it. No such file or directory. Oh, because it thinks it needs to be in that directory. No, it's just right straight up here. So you can read like that. All right, so now we have the sign. And now it's taking all these points and it's making the animation. What's the problem with it? Type is left hand, right hand. We have all these columns, so this should be good. But it's breaking here. Train file path equals path to sign. Hey, Rye, thank you for subscribing. What do we got here? We have Rye. Do you think Rust will be more used in ML in the next few years? Not in the next 4 years, but maybe eventually. Rye, thank you so much for subscribing on Twitch. Let's go ahead and spin this wheel. For you, how long have you subscribed? 9 months, Rye. Thanks for being here. Thanks. I appreciate it. Sign being shown here. So it's just this print statement. Here's my animation. This was me. That was me going shh. Right? That's my animation. And then the prediction for this. We almost need to make another one that's the prediction. Should we do another sign? I'm so excited about this. I can't see the chat now. The chat window won't let me log in. I don't know what you guys are saying. Is there a way for me to get into chat here? New comments on this? Chat. Ah! Stream with studio? No, I don't want to upgrade. I want to watch the chat somewhere. I give up. What are you guys saying? Someone just email me so I know. Docs. We need chat here. Load. Oh, don't make me log in and then have a window that won't actually go through. That's annoying. Powered by Restream.io. All right, let's just look at Twitch chat. Email. Someone send messenger pigeon. Yes, okay. That's what you're saying. And then YouTube chat here says, cool. Rob, would you mind doing a video? Okay, so there's nothing really that new. Let's do some new signs. ASL. Let's try. We could actually make our script take in the name of the sign that we're trying to do, but let's not get ahead of ourselves. Let's try something else. Let's try, going to this train sign value counts. And let's do, oh, bird. Let's do bird. I know what bird is. It looks like this. This is bird. This is a sign for bird. This is duck. What I'm going to do is I'm going to first do bird and then I'm going to do duck because I know these models and I know they're pretty bad at knowing the difference between bird and duck. Bird. Look, that's a little bird. I like how it does it sideways. Cat like eat bird. Oh, that's funny. So bird. We're going to practice doing bird into the camera with my little script that'll pull it in. Let's go ahead and let's have some fun here. So capture sign. Get ready. Bird. Escape. I might have done the beak thing too many times. All right, so now I'm going to move this output parquet to bird. And then I'm going to capture sign again. Duck. Maybe I shouldn't say it. All right. Let's move this output to be called duck 0.parquet. And let's run our model. Now, if the model is able to predict on my data the duck and the bird, I'm going to be impressed. So I'm going to move this up here. Let's call this a function to predict sign based on parquet. MediaPipe parquet. Let's call it that. Get prediction. And let's call this, let's give it a prediction function in the parquet file. And then let's have it print sign, not sing, sign. Let's call this pred and call this sign. All right, so we're actually taking the prediction value and the sign. So we'll just do this. That's like the ordinal value of the prediction, and the sign is this. We should actually also get the prediction. The sign, the prediction location. So this is the location of the prediction, 194, and it says there's no key name. Oh, that's because I need to do it like this. What I'm trying to do is actually get the prediction at confidence. So that's like the confidence of the prediction with confidence predconf. Get prediction. And we're going to give it our parquet file and see what it comes up with. Sign reference before assignment. Yeah. All right. So sign predicted sign. And the confidence is this. So 0.58, it predicted that was a Hey, Dead Sippy, welcome to the family. Thank you. ASL is so silly. Why is it sign? Word sign, sign. Yeah, you got me. Thanks for subscribing. Subscribe with Prime, Dead Sippy. Thank you for doing that, taking that away from Jeff Bezos for me. All right, let's go and spin the wheel for you. Sorry for screaming. I'm just really excited tonight. Oh, so close to having me scream Kevin as loud as I can. But instead, just going to sigh for you. All right, so let's get our prediction. It's a moment of truth for the bird. Predicted sign was goose. What's the ASL for goose? Let's look at goose. What does goose look like? Oh, it's so close. It's this. Look, I'm learning ASL, so I apologize if I'm doing this wrong. But this is goose. This is bird. This is duck. Goose, bird, duck. Models have a hard time distinguishing between those. Rightfully so. So let's go close this stupid chat window, which doesn't work. It still has a low confidence of that. And then let's do duck. Duck parquet, the parquet. Predicted sign duck. With a confidence of 0.999? What? Are you serious? Are you serious right now? How did it know that was duck so confidently? I must have done a really good duck sign there. Let's see the animation of it. Shall we? Now, what's going on here? Why don't we make these all into functions? Let's get rid of all this text too. Animate sign video. All right, so we are going to pull this stuff down that's not in this function and put it down here. We're going to get rid of all this other stuff. All we want to do is show her the sign. This was our shush. That looked like a shush. And then we're going to show the bird, which it thought was a goose. It was a big old goose egg. Maybe I just signed it wrong. Yeah, I kind of did like a forward motion with my... That's on me. That's on me. And then the glorious duck recording. It knew without a doubt this is a duck sign. Let's take a few more requests from chat. Oh, wait, I forget that we don't have good chat here. So Twitch chat. Second raised finger might be a big difference. Yeah, it is. So can someone give me a... out of all the signs, possible signs in ASL, what ones do we want to do? Let's take two signs. Let's do 3. From chat. Twitch, you guys get 2. You get 2. How does the animation show my feet? Because it's trying to detect a pose. Sorry for picking my nose right there. It's trying to detect my pose, and there is not my whole body, so it's failing. Chicken! Someone wants chicken? I don't think that's in the list. All right, so let's define some ground rules here. It might be in the list. Out of these, oh, you guys can't read this probably. Out of these, is chicken? I think we're out of luck with chicken. It's not in this. It has to be in here. Can I put this in the chat? It's probably too long for the chat. Twitch, what do you want? Donkey! Donkey and zebra. Those are the first ones I see. Zebra and donkey. Zebra and donkey. Those are coming from Twitch. Donkey, zebra. All right, YouTube. You guys get one shot at this. Don't screw it up. Not this YouTube. This one. I see wolf and I see brother. Wait, police. Police that was the first one, right? Police. Sloth. Is sloth in there? I want to see police. Is police really in here? Police is. We have a winner. Winner, chicken dinner. But chicken is not a word that we can do. Okay, so donkey, zebra, police. Now what we have to do, step 2, figure out how to sign these. Step 3, profit. All right, so we got to do donkey first. ASL donkey. Ooh. Okay, so we're doing the one-handed version. Oh, that's cute. Like this. Okay. Do you guys see? Like this. Wait. I need to do it like he does. Hand up and then wave twice. Wave twice. All right. Does that look good? Do I have approval from you all? Alligator. I take that as approval. Let's go to my terminal. Let's get ready to donkey. Ready? That kind of stunk because I need to make the camera be up a little bit more. Let's try that again. Try this again. Moment of truth. All right, so we have our donkey. Donkey 0.parquet. The next one was zebra. ASL sign for zebra. Oh, it's like stripes. Stripes. Okay. I think I got that one. All right, let's do it. Let's do it. Zebra time. All right, we got our zebra. We got our zebra. And then the last one was police. Signs for okay, so this one has a bunch of them. Stop, hospital, arrest, alphabet. I just want police. Police. ASL for police. Okay, this lady's videos are good. Oh, you do like this? Does it need to be like this? I guess it doesn't matter. I'm just going to try that. I'm going to try that and see how that works. Okay. Back to here. Here we go. Escape out of that. Let's see. Move our output as police 0.parquet. Here we go. Here we go, y'all. What's the scenario? All right, let's go ahead and do the prediction. We start with zebra. Oh, I didn't name it zebra 0. And then we started with donkey. Then zebra, and then police. All right, I need a vote in chats. Who thinks this is going to work? What are we thinking? 1, 2, or 3 out of 3? I guess 0 to 3 out of 3. Vote now. Vote by just writing how many you think. Twitch, you too. What's up? How many of these signs do we think it's going to get correct? 3 out of 3? People are confident. Do a poll. New poll. How many will the model get? 0, 1, 2, 3. I'm lonely. We're going to make this a 2-minute poll. We're making this a 2-minute poll. Some people think 2. Someone thinks 3. A lot of people think 2. Why? Which ones of the 2 is it going to get? Which ones of the 3 is it not going to get? I think 1. I don't know. You think I did the police right? I need to practice that. You guys are a little bit more confident than me. Okay, someone's doing 1. Nobody's lonely. I like that. Whenever you're in this stream, you're not lonely. If you're on YouTube, go over to Twitch. Okay, YouTube people are voting too. Some 1s out of 3, some 2s, other 1s. While this poll is going on, I'm going to end the stream as soon as I'm done running those cells. We'll see how well the model did on these recordings. I just want to tell you about a few things. Now, since I don't have my normal chat up, I can't really just put it in everything. So I'm going to do !YouTube. This will give you my YouTube link, which is youtube.com/@RobMulla, which I will also paste in there. And I'm gonna paste it into the YouTube chat, even though you guys are already at my site. So why would you need the link? Then I also have Twitter /Rob_Mulla. Hope that one's right. Yeah, that's me. And then I'll put that in this chat. We also have a Discord. Should definitely join our Discord if you haven't already. So that is in that one chat, and I'm putting in this chat. It's very unorganized. And then we have our Kaggle competition. So if you want to join the community Kaggle competition that I've been doing, it's the PogChamp series on predicting how much I sleep. I've provided you all with 8 years of my data of how much I sleep, of all my workouts, everything from my Fitbit and watch. And you need to predict my last year and a half worth of sleep. Every night, how much did I sleep? If you win that, if you do that good, if you win that competition, you get that NVIDIA 4080 GPU I have back there. If you just join, you have a chance of getting that 3080 GPU back there. So there's no point of not joining it. I just put the link in the chat. And the link, do I do live stream on a fixed schedule? Usually it's Tuesdays, Thursdays, or Sundays, but I'm kind of on my own schedule, so it's whenever I feel like it. This is the PogChamp competition, 116 people in it. First place is winning on the public leaderboard by a good bit, but still a long time to go. We have until May 1st that you can join and potentially win one of those GPUs. So definitely do that. What else do I need to do? No, that's it. I think we're there. Let's look at the poll results. Most people think 2 out of these 3 will be correct. Next up, people think 1, and then no one is lonely and no one thinks 0. Moment of truth. Let's do it, people. Up first is Donkey. Before I show it here, I'm going to show the animation. One thing to keep in mind is the detection might screw up. Okay, so that's my Donkey. So I did this, which is supposed to be Donkey. Let's see what it predicts. Donkey with a confidence of 87. Yes. Pretty good. So we're 1 out of 3 correct. There's no 0 out of 3. Next up is Zebra. If you don't remember, when I signed it, MediaPipe pulled it in. It looked like that. I did a good job there, right? It's like this. Zebra. I think we're going to go 3 for 3 here. Signed Zebra predicts with 0.9961 confidence. 2 for 3, people. 2 for 3. What's next? I should never have doubted you all who had said 3. I think I convinced many of you to switch to 2. But this is a moment of truth. Is number 3 of 3 actually going to work correctly? Let's build up some drama. Let's check the chats. No one's saying anything. Nice. Detected all your fingers. And this person has eyes. Road to 3 Pog. All right. Without any further ado, let's look at our police sign. It's that C on the side. So I don't know if I did it, like, does it work if you're doing it this way or this way? I don't know if it has to be a specific hand. We're going to find out. Police. It predicted police with a confidence of 0.66. But it predicted all 3 right. Let's go. Let's go. Nice, everyone. That was fun. That was a really fun stream. I hope you guys had fun. I'm going to go ahead and sign off here. Follow all those links. Join our Kaggle competition. Let's find someone to raid on Twitch. Raiders away! Who is streaming on Twitch? Coding with Strangers. We're going to raid Coding with Strangers. So stick around if you're on Twitch. We're raiding Coding with Strangers. He's doing some Python, some speech recognition. This could not transition any better. So make sure you stick around if you're on Twitch. If you're on YouTube, you just go bye-bye. Go watch some other videos. No, or jump over to Twitch and follow that. So let's go ahead and get ready to raid. And I will see you all next time. Thanks for hanging out with me. And I'll see you guys on the leaderboard of Kaggle. Have fun, everyone. Be nice and love each other. And I will see you next time I stream. We detected 3 for 3. Actually, 5 for 5 if you count the other ones. Maybe more. I forget. All right. Have a good time. All right, YouTube. You guys have a good one. Bye-bye.